Good day everybody and welcome back to the channel. I was watching a couple of my own videos from recent, including the last upload, and I've noticed that I'm picking up a habit of doing things, how do I explain this? Instead of preparing first, I'm doing a lot of things like this schematic I drew the other day. I drew this almost on camera. I basically paused my recording, did a quick mock-up of this and then came back. When I watched the video back, I realised that there was so many things wrong with it, it wasn't funny. So something I'm going to be a bit more conscious of in future is preparation, because that's not something I've not really put much thought into until now, but yeah. So my apologies. I'm now going to point out what I did wrong, and then we'll get into the rest of the video. So again, my apologies, and I'll be more mindful of that in future so I don't keep doing that. A few things. In the last video, I said something stupid without explaining it. I was talking about adding resistance to the common line going back from the cap bank to the output. Now, I meant something really small like 0.1 ohms, 0.22 ohms, nothing more than that. The reason for that was because I was thinking about the fold back current resistor. And I was thinking about adding resistance on both lines to give some common mode rejection on the output. But the more resistance you add, the more it ruins the regulation and a few other things. So I decided to just leave that out. But when I was watching over the video, I didn't really explain any of that. And I just thought I should point that out, because I don't want people just going and breaking the negative line of their circuit and adding resistance to it. That's going to ruin all your filtering. Normally all your filtering is getting shunted through caps back to the ground rail. Yeah, so this is only applicable for low currents, low regulation, floating circuits that need common mode rejection. I should have pointed that out. We're doing all right with this already, and by the time I get that filter on the front, as I demonstrated in the last video on the scope, that'll be fine. I've drawn in the missing capacitors that I mentioned. I also put a comment in that video saying something similar. There's a few reasons for it, but anyway, I basically put a comment in saying don't do that. Anyway, I drew in the capacitor that goes across these two diodes and the capacitor that goes across there. Those are both question marks. So this is now the correct schematic with the two missing things drawn in. What I'm up to doing now, and just for reference, if anyone missed it in the first video, that's the simple ass power supply. Alright. Cool. That's our star grounding point for the ground. Now, the circuit board, I took some measurements of the case, and I was able to fit a slightly larger board in there, which is a wonderful thing because it gives us more space to work with. You might be looking at the board right now thinking, Dave, that's a bloody big board. Why are you worried about that? Well, this is why. Not such a big board now, is it? So that's a bit of a problem. As you can see, I'm designing the board the same way, so it's got the same slit there. The way it sits in the power supply, the capacitor's got basically a U that sits around here on this end of it. This end attaches to the board, and the board's got this slit. And then you also do up the transistor. doesn't seem right to me. And I can see a little hook in here, like, you know what? It wasn't me that did this. I pulled it apart and everything I pulled out of it is in here. But I'm just noticing capacitor rests here. It's secured to the board there. Board clips in here. Driver transistor goes there, but those two hooks would have had some sort of spring around them. Excuse me. I can really talk, I'm sorry. Oh man, these things come at the worst time. I'm really trying to make a go of the channel. I just promised everyone that I'd be pumping out videos and I get sick. My life, I just can't win. Yeah, so, I don't know, it's a bit odd. It doesn't bother me, it's just going to be sitting on my desk and it's not like that's going to be going anywhere. And that's solid fiberglass board, so we'll be fine. But yeah, just an observation. The other thing I'm going to salvage, I've got some that I've salvaged anyway, but I'm going to salvage the fuse holder because I'm going to fit a fuse in this. Or I might actually put I might put a 10 amp resettable fuse in the front of it. I know 10 amp seems a bit high, but at lower voltage, I wouldn't be surprised if this thing can do 10 amps. The transformer's actually got it's quite a big transformer for the box it's in, and the winding on it is quite thick. I think the transformer's main restraint is actual power, not so much current, if that makes sense. So VA is what I'm talking about. Anyway, the 10 amp resettable fuse, or I'm going to salvage that. I'll make my mind up on it. I might end up just salvaging that because then I can put exactly an 8 amp fuse in there or something like that, you know, which is what I'd rather do. There we go. This thing was made in 1991 or 92. Cool. Anyway, so that's the size of the board. I'm going to go off now and cut this board, drill the holes and cut that little slot, or just, I guess, drill a couple of holes in it and just run a drill bit through it. I don't know, I'll think about how I'm going to do that when I get to it. I still got to go buy proper drill bits to cut through the hard steel panel. This case, yeah, that's not soft steel. That is hard steel. I'm honestly shocked. Like, you'd think it'd just be mild steel. No. It's the full Monty. I tried drilling through it with normal steel bits, and I'm going to have to go get some HSS bits. Like hardened steel, whatever. What are they for concrete? I can't remember. You know what I'm talking about. The ones for cutting into high tensile steel. Anyway, because I'm sick, I didn't get in my mate's car and get a lift to Bunnings today because I didn't want to get him sick. But we're going to go tomorrow, so I'll get the front panel sorted out tomorrow. I've got cut-off wheels for my Dremel. I've got drill bits that will cut through this, so I can at least do this, and then we can start making up the PCB. So at least I can be doing something. Alright, well, I'm going to go cut this and come back and we'll start laying it out. I probably won't sit there and just lay it out on camera, but we'll talk about a few key things. Once it's cut out and this slits here and those holes are there, we can mount the capacitor, we can do a few things to, you know what? I'm a bloody dumbass. I've done that the wrong way around. I'm gonna have to I'm gonna have to get IPA and remove all of this, which is not a problem, honestly, and invert this because I need this copper on the back. All good. I'll do that. When the board's cut out, we'll mount the capacitor to it and stick it in the slot, and then we'll be able to work out where our driver transistor needs to sit to bolt down to the case in relation to the board, and we'll just draw 3 pads on the board where that goes, however it goes, you know what I mean. And from there, we'll be able to design around the capacitor. We'll draw a circle around the capacitor too, so we know where it is. And then we'll have our space. We can take the capacitor off. We know where our driver transistor has to mount, and we can just design the circuit around the usable space. So that's the plan. All right, well, I'm going to go get off to cutting. Sorry. And I'll come back and show the cutout and how it fits. And then I'll get to marking it up, and I'll come back and show that, and then we'll etch it. So as I was cleaning this board up, I was doing some thinking, and just for the purpose of, you know, not entertainment, but education, I just wanted to point something out. I'm going for a low noise design here, but we could get more regulation. Well, there's 2 things I still got to look at. I've still failed to mention one thing in terms of the schematic. Where is it? This 2.2K resistor. Yeah, we've got 2.2K. We might end up changing this to something like 1.8. You know, to get more current through the zener for better regulation. We may... Oh, you know what? I forgot to draw in this schematic too. Now I feel really silly. Big boo-boo there. Let me just move this off to the side. Damn, I feel like an idiot. Because I showed this to people in the last video. I hope no one's copied it. Oh my god. That would not be good. So, how am I going to do this? Yeah, well, that still works. I just need a bit of space here. We have currently a... My apologies, let me just test this resistor. I literally can't read the bands on it. Alright, currently we have a 1K resistor here. We may also go down as low as 560 ohm, probably around 750. Oops. This will all get tested on breadboard, not on circuit board. The only thing we'll test on circuit board, like I said, is the compensation, because that has to be done at the end. But the other thing I was thinking of, well, where we have our driver circuitry, with full wave rectification and the 2 stage RC filtering, this gives us about 22 volts with the load that's on it. When I increase the load, maybe 21.5, 21 and a quarter volts, something like that. Now, sorry, 21 and 3/4, maybe 21 and a half. Yeah. Anyway, which will still be enough, but I could get the circuits to have better regulation and possibly even get a bit more power out the output stage, if we change just this portion of the circuit by taking a line off of the AC and a line off of the bridge, form a voltage doubler, and then two-stage RC filter that, and then put a zener, a dropper resistor and a zener, and then another filter, and then drive our driver's circuitry off of that. That will provide a higher voltage with a stable voltage at this point. See, at the moment, when the voltage gets dropped across here, as this comparator transistor sinks more current, also voltage is slowly dropping across these two as these capacitors are discharging. Now, I've measured it and it's not noticeable, so it appears most of the voltage is just quickly dropping across the other one, but it still could be improved for, like I said, regulation and output power. So that's what I'm thinking about doing, is basically modifying that bit of the circuit, and it won't take much. So I'll be able to literally just draw an extra line from here, change, I'll just erase this section here, that will stay there, or this will stay here. Another line will come in and I'll draw a new section here with a driver output. And yeah, so that's just the couple of things that I wanted to point out. So yeah, maybe some more changes still. Maybe I'll make a 6-part video, not a 5-part video. Who knows? Probably not, because I'm probably just going to make these changes in this video, then still etch the board up and all that in the same video. So I'll probably still keep it 5 parts, but if it starts to get too long, I'll make it 6 parts. Anyhow, I just wanted to point that out. So I'm going to get back to sorting this board out now. No, don't play with that. I'm going to get back to sorting this board out now. As you can see, I've cleaned it up. I've got to go cut it to size and mark it. But that schematic, I know I said this before, it's not going to get changed. Look, it's not getting changed. The things that could get changed, I'll put question marks on, and I just forgot a resistor there. All right, so that is the final schematic. The only other thing that, like I said, might get changed, or probably will get changed, is this driver stage just here. I may make it a voltage doubler with a zener regulator. The problem with all this is this also adds more load and more ripple. So see, with the 4-wave rectification and the 2-stage RC, you've got, you know, less, what do you call it? Less voltage there and less regulation, but you've also got less ripple. Now, I could also incorporate a zener into this. I could load it at, say, 18 volts at 1 or 2 amps, whatever I decide it's going to be. See what voltage the driver stage drops to, if it's, you know, high enough for the comparator transistor in terms of voltage. We could possibly implement a zener with 4-wave rectified. I've got to do some tests on that, so I might not even have to make a voltage doubler. We'll just have to see. But either way, we can get way better regulation by potentially adding a little bit more current. I'm not sure. I think I'll go over my last video. I think I actually experimented with the value of that and had a look at the accuracy of it, and it didn't really change. 1K was fine. Anything below that didn't improve it. I can't remember, but I'll have a look. But as for this, I know lowering this improved the regulation. So I'll have a look and see if lowering it a little bit more improves it anymore. The thing is, although 2.2k at 22 volts is, I can't think. Or do I measure it at 24 volts? I can't remember. It's I don't know, maybe 20, 30 milliamps. I can't remember. I really can't remember. Anyway, the thing is, with the voltage drop across the comparator transistor and the zener, there's not actually that much voltage left flowing, so there's actually not that much current flowing, so that's why I want to lower the value of that resistor. Anyway, yeah, that's that. So, might become voltage double, might not, but we will get one more zener in here, so it will have 3 zeners. Alright, I'm going to go do this and I'll be back. Alright, I just did some quick math because I felt like an idiot not being able to calculate that. So basically speaking, if this transistor was a short circuit and this zener diode was a short circuit, so these two components weren't here and current was just flowing straight across here, with a 2.2k resistor we would have a max of 10 milliamps. Obviously we've got volt drop on here depending on how open or closed this junction is, and we've got the 5.1 volt drop here too. So let me just go redo the calculation with the 5.1 volt taken off of it. Oh, be one sec. Actually, under load, there's also an additional 2 volts missing. So let me go subtract 7.1 volts. I'll be back. All right, that works out to about 7.8. And that's when this is closed all the way. Actually, it'll be about 7. Let's just call it 3. Because even when this is closed all the way, it doesn't go into saturation. There's still a 0.6 volt drop across here. So, all right, so 7.3 milliamps. Yeah, I'm going to change that to 1.8k because I want at least 10 milliamps flowing at the bottom end when it's letting as much current flow as it can. That'll bring this zener into regulation, better regulation over a wider range. So I'm going to change that to 1.8k now. Let me just do that, power it up, make sure. Actually, what's the wattage on that? 1 second. All right, so we've only got 0.123 of a watt. So, let me do the calculation, bumping it up to 1.8k. 0.151 of a watt. So that, I don't even need to turn this on. That transistor's never going to get warm. We could actually, I'll tell you what, I'll put a 1.8k in now. Let me just move this all off to the side. I'll put a 1.8k in right now. We'll test it out. We'll test regulation. Let's do a few experiments. That way I can note down the values. Let's do something. Let's play around with this resistor value. I'm pretty sure 1k was as good as I could get it. But this one, the 2.2, let's play around with that. I'll get the load bank sorted out and I'll be back. Well, that was interesting. I put it all here, set it all up, you know, turned it on and got zilch. Small fix. Apparently, negative wire has come off. So I'll just reflow that. That must not have been soldered on very well. Oh well. Alright, we'll try that again. Oh, what do you know? It works. What a surprise. I hook my load bank up. Okay, so 18 volts. I'm going to set 1 amp. What do we drop? That's pretty good. That is already good. Alright, let me go get a 1.8k resistor. I'll be back in a sec. Alright, I've actually grabbed the 1.8 and a 1 because we're not even on 1/4 of a watt for the transistor, so that's fine. 1k probably will be about 1/4 of a watt, or maybe still shy, but anyway, I'm going to put the 1.8k in here first. No, I don't need to turn it off to remove this component. See, there are some components in this circuit that if you remove them whilst it's powered on, the comparator transistor will go up in smoke, well, without protection diodes, and other components it will just power down and then power back up. It just depends what you're pulling out. Anyway, that's 1.8k in there now. Let's give it a nap. It's 96, 97, 98, 99. That's what, 80 millivolts, and with our 2.2k we had, I really should have taken that measurement first. I know. With the 2.2k we've got wait, what? Nine, 1 plus 7. Oh, yeah, that's 90 millivolts. Let's go down to 1k then. We gained 1 millivolt of accuracy by lowering it by a smidgen. Let's lower it by a bit more than a smidgen. So yeah, I'm definitely going to put more preparation into these videos, but I'm still going to make this an engineering blog. So you're still going to get to see me doing stuff like this, designing a circuit. But what I'm going to do is when it comes to making schematics and stuff like that, I think I'll just wait until the end, or we'll just draw it as we go and talk about it. But I won't say, hey, this is the end schematic, because I rushed that and got it wrong twice. Not my circuit, but I missed stuff out on the schematic, which is, I just genuinely feel bad if anyone's trying to play around with this stuff at home and I'm screwing their project up. That was my concern. Yeah, not even warm. All right, 18.07. It doesn't look like we're going to get better than that. Okay, well, I'm pretty sure that's what we had with the 1.8k. Let me just count. 98 to 7, 99, 100. 1, 2, 3, 4, 5, 6, 7. So that was 90 millivolts. Wait. 93, 94, 95, 96, 97, 98, 99, 100. 1, 2, 3, 4. What? That's way worse. Have I got... Oh, I've just realised what I'm doing. That's the bloody 1K RC filter resistor I'm changing. Whoopsie. I put that back in. I'm changing the wrong bloody resistor. No wonder I'm looking at the results going, huh? Okay. Incidentally, it's day 3 and my nose isn't completely blocked now, but I am getting better, so that's great. For those of you that don't know, I've got a cold. But I should be fine because I only usually get colds literally once in 2 years. And they usually last me about 2 or 3 days. So the day before yesterday, I absolutely did nothing, basically. Yesterday, I did a little bit, and today I'm feeling quite good. Alright, back to 2.2K, 18.9, 1 amp load, 18.2, that's pretty good. 3, 4, 5, 6, 7, 8, 9, 10. So, yeah, 80 millivolts at 2.2K. Okay, let's just go straight to 1K. Oh, wait. I think that is 1K, but again, because of the bloody resistors, I can't read it. It's alright. Plenty of meters here that can measure resistance. Yes, it's 1K. So 1K got us 80 millivolts. Let's put the 2.2 in there. Hello, little man. Let's just wait for that to warm up those diodes and transistors. Yes. It'll take a bit longer because it's a 2.2K, so there's less current. Hey, no. I've got a board up here that I've just cleaned. Don't need fingerprint oil or cat pad oils on the copper. Alright, 18.7. Then we're going to get 18.8. Yeah. Alright, 18.8 to... Okay, so that's 80 millivolts again. So, it doesn't seem at the bottom, at the top that it improves it. That's probably my own stupidity because it's turned all the way up to the top. So we're probably going to see more of, hey, don't play in here, come on. I'm trying to work. We're probably going to see more of a difference if I turn it down to say, if we had it right there, it would be literally comparing the output against the reference, and they'd both be the same, so you get your best regulation there, I guess. But yeah, let's just load it. I'll put, let's see, 6 amps, 7, 80, 78, 79, 80, so what, 30 millivolts with a 2.2K. Let's just go straight to the 1. Alright. Okay, we do really actually want a higher resistance there. That's interesting to me. I think it's because we're limited with voltage headroom in the circuit. So if we load it down too much, we drop too much on the 1K resistors, and then we're actually falling out of regulation because... No, we'd still have enough drive voltage. I don't know. did not move that much a second ago. That's the 2.2K. Just making sure there's nothing loose that's affecting regulation. Did I read my meter wrong? 71. 91's 10 plus 4, 14. What's 140 millivolts, 6 amps. Just for shits and gigs, I'm going to go get a higher value resistor. I'm not quite sure what's going on here. That just seems a little bit odd to me. I'm just going to grab a 4 point. It might be a bit high. I'll go for a 3.9K. Just for shits and gigs to see what happens, because I would have assumed sourcing more current to the zener would give it a tighter regulation. No, it does want more current. We're just on a fine threshold of availability and how much we can use to drive. So that voltage doubling circuit that I was talking about would actually come in quite handy here. Okay, well, you know what? That value is going to stay 2.2K. I'm going to leave the video here and I'm going to have a think about if I want to make a voltage doubler. I'll also, let's put 8 amps. Alright. Let's see what our input falls to on the second stage at 8 amps. Wait, what? How is there only 16 volts there? Oh, because it's getting dropped across the 1K resistors too. Yeah, I forgot about that. Yeah, this poses a problem. What's that do loaded? Yikes. Okay, well, excuse me. I've got some considerations to make, don't I? As is, or voltage doubler and add more regulation. But I think I'm going to work that out before I go and put the circuit board together, obviously, and update the schematic. So I'll end the recording here and I'll do that. I think I'll just post this little update quickly because I feel really bad about not making proper preparation for the last videos and the schematic being wrong. As you can see, everything's now on here. Like I said before, you know, the driver circuit for this line here may get changed to a voltage doubler circuit. That's this portion. But other than that, I can at least now say that this is the actual circuit. This, I can tell you now, this resistor won't ever get changed to 1.8K. What may happen is if we make a voltage doubler circuit, this may end up being, say, 4.7K or 3.9K or something like that. It might go up, but I've had a fine look over this now. I did my preparation, and I can tell you this is the schematic that we are going to be using for the circuit. minus fold back currenting if fold back current if I add it. And like I said, that resistor could be higher and we could have a different power driver. But yeah, I'm going to upload this video now because I feel bad about the last couple of videos for people that are trying to play along at home, or even just people who are learning. So I'll upload this, and then I've just come in here to start work for the day. It's only 1:40 p.m. I've got hours today. I'm going to start measuring and cutting this up, and yeah, we'll come back in the third video, and I'll have the PCB cut and all the traces drawn on it, and we'll etch it together on camera and start populating it. Like I said, I'm just going to have a quick think about this, if I want to change this circuit or if I just want to keep it as it is. Yeah, I'm going to do a bit of umming and ahhing. I've got to do some thinking, you know. It's ultimately what I want. That's what it comes down to. So, without further ado, I'm going to sign off here and just leave you guys this update so that no one's confused, and get to work on this. I'll see you in the next one later on today.